Myself, K. Sirisha, working as assistant professor in mechanical engineering department in Indian College of Engineering and Technology. Today, we are going to do some problems regarding first of thermodynamics of open system of study flow energy process. So now start with problems. A turbine operates under steady flow conditions, receiving steam at the following state: pressure 1.2 megapascal, temperature 1.188 degrees centigrade, enthalpy 2785 kilojoule per kg, velocity 33.3 meter per second, and elevation 3 meters. The steam leaves the turbine at the following state: pressure and nothing but P2 20 megapascal, enthalpy H2 2512 kilojoule per kg, velocity 100 meter per second, and elevation 1 meter. Heat is lost to the surroundings at the rate of, lost is nothing but Q is equal to minus 0.29 kilojoule per second. If the rate of stream flow through the turbine is 0.42 kilojoule per second, what is the power output of the turbine? That is nothing but a power output of P. We are going to find out the value of P of turbine. So this is our turbine. This is our turbine. Shape is like that. Here the mass in heat is lost. That is nothing but heat out of the system. And always turbine is a power producing device. So power system done by the work done W and loss from Q. So this is control volume, and this is boundary and mass in. Okay, so here mass of steam received from boiler. So let us check the problem. So here, if the rate of steam flow through the turbine is, rate of steam flow for the turbine is 0.42 kilojoule per second. That is nothing but mass flow rate, mass of the steam received from boiler, m dot per second is nothing but already I said the previous class. Whenever the dot above the m, it will indicate that per second time given. So m dot is equal to 0.42 kg per second, and heat loss is equal to 0.29 kilojoule per second. Okay, so we divided with each other. 0.29 by 0.42 gives 0.690 kilojoule per kg in the form. Okay, m is nothing but mass, 0.29 by mass. So finally we got 0.690 kilojoule per kg. And next, start with problem. For inlet parameters, what is the turbine inlet parameters? This is our turbine. So here this is inlet of turbine and this is outlet of turbine. Or inlet P1 T1, and this is outlet of turbine. So what are the those values of inlet of turbine? So inlet of turbine pressure 1.2 megapascal, temperature of inlet T1 is equal to 188 degrees centigrade, enthalpy is nothing but H1 is equal to 2785 kilojoule per kg, and next velocity 33.3 meter per second, elevation is nothing but Z1, that is 3 meter here. So pressure, temperature, enthalpy, velocity, and elevation is nothing but Z1. And next, steam leaves the turbine is nothing but outlet of turbine. What is the outlet of turbine? So P2 pressure 20 megapascal, enthalpy H2 2512 kilojoule per kg, velocity 100 meter per second, elevation Z2 is equal to 1 meter. So output of the turbine, already we derived the equations for turbine, compressor, nozzle. Okay, from actually this is output of turbine. So from what do we know the steady flow energy equation? So we have to remember the equation of steady flow. So what is the steady flow energy equation? If you know the steady flow equation, we can easily do the problem. Okay, so what is the steady flow equation? Energy for steady flow energy equation: H1 plus H1 is nothing but enthalpy, V1 square by 2 is nothing but kinetic energy, and G into Z1 plus potential energy plus Q. Here Q, heat loss, is equal to H2 plus V2 square by 2 plus Z2 plus W. This is the steady flow energy equation. So by take the equation, we are going to solve the problem. here q is taken as negative because of heat is lost. Already I told you. Here what he said, steam leaves the turbine and heat is lost. Whenever the word loss is given, that is we taken as negative value. Okay, we put here. Actually, this is the steady flow energy equation. H1 plus V1 square by 2 plus GZ1 plus Q is equal to H2 plus V2 square by 2 plus GZ2 plus W. So this is the equation for steady flow. So by depend upon this equation, we are going to solve the problem. From above the problem, what he has given, so q is negative because of he given q lost. So lost is nothing but take negative value. So w is equal to h1 minus h2 plus v1 square minus v2 square divided by 2 plus g into z2 minus z1 minus z2. Here q is taken as negative. So put all values here. What are the values of inlet parameters and outlet parameters of turbine? So put all values here. So here h1 value, h2 value, v1 square value, v2 square value, and next g is 9.81. So elevation is 3.3 minus 1. Here why you considered 1000. Why you consider 1000 nothing but or kilo here, or work done is kilojoule per kg. Here q also, here, here also we take it in the form of kilojoule per kg. Okay, enthalpy also kilojoule per kg. So all terms are given in the form of kilojoule per kg, kilojoule per kg. So that is why we divided 1000 by 1000 and 1000. So if you divide by 1000 and 1000, we get the kilojoule per kg. Okay, so 2 divided by 1000, and here also divided by 1000. So divide all the 1000 into 1000, we got actually our enthalpy value is kilojoule per kg. Here kilojoule is satisfied. Here h1 minus h2, kilojoule, but here it is not meter per second, and this is also gender is meter. So we want kilojoule. So that is why our answer we got in the term of here q also in kilojoule form. What is our q value? Here 0.29 divided by 0.42. So here q is also in the form of kilojoule per kg. So our balance should be here finally work done also kilojoule per kg. Here h1 and h2 kilojoule per kg, q1 also kilojoule per kg. But our kinetic energy and potential energy, uh, now we are satisfied with both are getting balanced. So we divided 2 divided by 1000 and divided by 1000. So finally our solution is balanced. We got w is equal to this value and in the form of kilojoule per kg. Okay, and next power is nothing but work done into m dot. So work done is 267.884 into m dot also given. Startly, what is our m dot? 0.42 kg. So work power is nothing but work done into m dot. So put the value work done into m dot. Finally, turbine output is 112.51 kilojoule per second. And next question is a steam turbine operates under steady flow conditions. What are the word given steady flow? It receives 7200 kg per hour of steam from the boiler. The steam enters the boiler at enthalpy of 2800 kilojoule per kg, a velocity of 4000 meter per minute, and the elevation of 4 meters. And the steam leaves the turbine at enthalpy nothing but H2 at a velocity V2 meter per minute and elevation 1 meter. Due to radiation, heat losses from the turbine, the surrounding amount to 1580 kilojoule per hour. Calculate the output of the turbine. Okay, here also we are going to calculate the power. Here is mass in and mass out. So Q loss from the turbine. So whenever the Q loss from the turbine, we get the work done by the system. Okay, this is control volume boundary. So first of all, mass of steam received from the boiler 7200 kg per hour. 1 hour is 60 minutes. In minutes, 60 into 60, 1 minute is 60 seconds. So 60 into 60, 3600. So 7200 divided by 3600 gives to 2 kg per second. 1 hour is nothing but 3600 seconds. Okay. And next, heat loss is nothing but Q. Heat loss is nothing but Q. So 1580 kilojoule per hour. Already 1 hour is 60 minutes, 1 minute is 60 seconds. So 1 hour is equal to 3600 seconds. So 1580 divided by 3600. So 0.438 kilojoule per second. So 0.438 kilojoule per second and kilojoule per second and 2 kg per second. So 0. Here m. So 0.438 by mass of the steam. M is nothing but mass of the steam. So what is the mass of the steam? 2. So Q is equal to 0.219 kilojoule per kg heat lost. Okay. And next, enthalpy. Turbine input parameters are enthalpy at H1 2800 kilojoule per kg, velocity 4000 meter per minute. Okay, meter per minute, 1 minute is 60 seconds. That is nothing but 4000 by 60, gives 66.667 meter per second. Elevation Z1 is 4 meters. Elevation Z1 is 4 meters. This is a problem. Here, elevation of inlet parameter of turbine is 4 meter. So 4 meter. And outlet parameters also for outlet of turbine, H2 is equal to 2000 kilojoule per kg, velocity V2 is equal to 8000 meter per minute, and elevation Z2 is equal to 1 meter. So those are all the inlet parameters and outlet parameters. Output of turbine. What do you know? First of all, we do know the steady flow energy equation. What is the steady flow energy equation? So m dot into h1 plus v1 square by 2 plus gz1 plus q is equal to m dot into h2 plus v2 square by 2 plus gz2 plus w. Okay, here q is taken as negative because of heat is lost. Okay, so w is equal to, so common both terms we have m dot, so m dot into h1 minus h2 plus v1 square minus v2 square by 2 plus g into z1 minus z2 minus q. Okay, here q is positive, but we take it in the form of negative because of q is taken as negative, heat is lost. So put the value of m2 already given. M2 is 2 kg per second. So 2 kg per second. So to H1 and H2 values from inlet and outlet parameters of turbine, 2800 minus 2000 plus we balanced for kilojoule per second. So we divided with into 1000 here by divided 1000 and 1000. So 2 into 1000, so 9.81 into 4 minus 1 by 1000 minus 438. Okay, finally we got here kg per second, here kilojoule per kg per second. So kg cancel, finally we get kilojoule per second. So what is the turbine output? Turbine output is nothing but power. Power is nothing but power in output is only, not he asked the power, he asked only turbine output. What is our turbine output? Turbine output is work done only. So he asked turbine output is work done. So work done is 1586.3 kilowatt. Okay, so it just divide to 1000 and 1000. Okay, next the gas leaving the turbine jet engine flows steadily into the jet pipe with enthalpy 960 kilojoule per kg and velocity 250 meter per second. The exhaust from the pipe is at enthalpy 860 kilojoule per kg and exhaust is in line with intake. Neglecting heat loss from the system, determine the velocity, gas velocity leaving the pipe. So first of all, gas conditions of gas inlet. So this is a jet turbine, this is jet pipe. So conditions for gas inlet. So what is the conditions for gas inlet? H1 is equal to 960 kilojoule per kg. So kilo is nothing but 10 cube into joule per kg. Velocity 250 meter per second. So condition at output. conditionate output is H2 is 860 kilojoule per kg. So 860 into 10 cube joule per kg. So he asked let the velocity of gas at the exit. Okay, applying steady flow energy equation between 1 and 2. So between 1 and 2 figures we are going to apply steady flow energy equation. So now what do you know? H1 plus V1 square by 2, because of there is no elevation here. So Z1 is equal to Z2, that is nothing but delta Z is equal to 0. Here there is no potential energy. So m dot into, here check once, m dot into h1 plus v1 square by 2 is equal to m dot into h2 plus v2 square by 2. Because of he did not give any information about the elevations, so we taken potential energy as a 0. And next, neglecting heat loss from jet pipe system. So here in this jet pipe system we neglecting heat loss, so q is equal to 0. So this is jet turbine and this is jet pipe. Okay, so this is jet pipe. So elevate q for a jet pipe, q is equal to 0. Neglecting heat loss from jet pipe, so put all the values here, by solving the above equation we get v2 is equal to 512.34 meter per second. So that is the velocity of jet pipe. So that is the exact velocity of gas, v2 is equal to 512.34 meter per second. And next problem, here it is also the same problem. Okay, next, the gas leaving the turbine jet engine flows steadily into jet pipe. So this is the jet turbine and this gas flow into the jet pipe. Okay, the gas leaving the turbine jet engine flows steadily into jet pipe with enthalpy 8000 kilojoule per kg and velocity that is nothing but v1 123 meter per second. The exist from the pipe is at enthalpy. So exist from the pipe is at from pipe enthalpy is H2 450 kilojoule per kg, and exhaust is in line with intake neglecting heat loss from the system, that is nothing but q from the jet pipe we taken as a q as a neglected in a jet pipe. And next, determine the velocity of gas leaving the pipe. So we are going to find out the same for the problems, we are going to calculate v2 value. So how to calculate? So take the given conditions. This is a jet turbine and this gas is going to the jet pipe. So here we have V1 and V2. Okay, and enthalpy H1 and H2. And now we are going to calculate the velocity of gas. That is nothing but V2. We are going to calculate it. So for conditions inlet, this is inlet conditions and this is outlet conditions. So that in the form. So from the jet turbine to jet pipe, this is inlet condition and this is outlet condition. So based upon these values, now we are going to calculate the velocity. So enthalpy H1 is equal to 800 kilojoule per kg and 809 into 10 cube joule per kg. And next, velocity V1 is equal to 123 meter per second. Okay, and next, conditions of gas at exit. So at exit, so enthalpy H2 is equal to 450 kilojoule per kg. And next, let velocity of gas V2. So now we are going to calculate the velocity of V2. So apply the steady flow energy equation. So what is in between 1 and 2 states? So we know, what do you know of steady flow energy equation? M into m dot into h1 plus v1 square by 2 plus m dot into h2 plus v2 square by 2. Here del z is equal to 0 because of there is no elevation given in the problem. Heat loss, q is equal to 0. Okay, if q is equal to 0, there is no work done. So w also 0. So neglecting heat loss from jet pipe system. So put all values here. Put all values here. Here also m value also not here m value also not given. So we consider as 1. So h1 plus v1 square by 2 is equal to h2 plus v2 square by 2. Because there is no value of mass, so that mass we will consider as 1. and next put all the values. What is h1? 800 into 10 cube plus what is v1? 123 square by 3, sorry, by 2 is equal to 4450. Here we have one doubt, ma'am. Before class we put for kinetic energy divided by 1000 and for potential energy divided by 1000. here Here we don't necessarily, here we don't want, because of we asked velocity, we didn't ask work done. If you want to calculate for work done, so divided by 1000 with the kinetic energy and potential energy. Here he asked only velocity, so that is why we need not put the value of 1000 for kinetic energy. So we just put the values here only. V1 square by 2 is equal to, for H2 is 450 into 10 cube plus V2. What is V2? We don't know the value of V2. We are fine. We are fine. We are going to find. So V2 square by 2. So put all values here. And finally, we got the value of 845.65 meter per second. So exist velocity of gas pipe. Exist velocity of gas pipe. Gas leaving the pipe is V2 is equal to 845.65 meter per second. So this is the problems. You just remember the water steady flow energy equation. So based upon the steady flow energy equation, we can solve the problems very easily. So this is the turbine inlet outlet, Q loss from the system and work done by the system. This is control volume, mass inlet and mass outlet. So steam received from the boiler is meaning of that, this is, so mass. Okay, here Q is kilojoule per second, but we want kilojoule per kg, just 0.29 by mass, and we got in the term of kilojoule per kg. So take the parameters of inlet of turbine and outlet of turbine. Okay, based upon taken these parameters and the output of the turbine. So take the steady flow energy equation and put all the values here. Here he asked power. So if you want to power, so power is nothing but work done into mass. So h1 minus h2 v1 square minus v2 by 2 plus g into z1 minus z2. Here q is taken is negative because of heat lost. So that is we consider minus q. So put all the values here. So that we are going to the values, find out work done. So for dividing 1000 uh, in kinetic energy and dividing 1000 for potential energy. So finally we got kilojoule per kg. So this is kilojoule per kg. This is a mass in the form of kg per second. So this is kilo, not this is kilojoule per second. Joule per second is a watt. So our answer is kilowatt. So turbine output is 112.51 kilojoule per second. So same here also. Inlet outlet mass in mass out, work done by the system, Q loss. This is boundary and control volume. So Q. So same problem. So put all the values here. Because of here also, here m dot is equal to kg per second. Here q also kilojoule per kg. Actually here kilojoule per kg. This is not kilojoule per second, kilojoule per kg. Okay, because of we want kilowatt, so this is kilojoule per kg. So here our velocity is meter per second. This is kilojoule per kg. So kg all is cancelled here. So finally we got kilojoule per second. So this kilojoule per second is what? So finally we got 5158 6.3 kilowatts. And finally, third problem also like that here. So this is our problems. Now today we end this class, and next continue some more problems. Thank you, students.